Hello everyone. Today we're going to solve some problem related to friction. The slide actually taken from my course teacher Imrul Kais sir. So the slide is not mine. Credit goes to my teacher. So I am ignoring the theory part. So yeah, that is our first question. So this very simple one. A 100-pound force acts as shown on a 300-pound block placed on an inclined plane. The coefficient of friction between the block and the plane are mu s. The static coefficient is 0.25 and kinetic friction coefficient is 0.20. Determine whether the block is in equilibrium and find the value of the friction force. So here is a block over here and that is an inclined plane. The angle of inclination can be determined from this triangle over here, which we'll do later on. But for now on, let's just analyze the question. So there is a block over here. You are applying some force inclined to the plane over here. The value of the force is 100 pound. So you have to determine the block will stay in equilibrium, or will it go upwards along the plane, or will it go downwards. So let's first determine it. So we will be needing the angle of inclination over here. That means the angle of inclination, that angle over here. So how can we determine it? We have a triangle over here. You have to find out this angle. So this can be determined by, you know, by sine, cos, tan, whatever you can take. So I'm going to take tan theta. So theta will be tan inverse 3 by 4. So it will come out to be 36.87 degree. So now we know the value of theta. So as you know now the value of theta, the angle of inclination, you can determine the reaction force over here, the normal reaction force over here, and as well as the component of gravitation force in this direction. So we will be doing this now. First determine the value of n, which is normal to the plane. Actually the weight, you already know the concepts, I believe. The weight over here, the weight of the block will act um, towards the center of the earth like this. No, now we will break this vector into two components. One component will be in that direction over here, and the other component will be in that direction. We are breaking the weight vector over here into these two kind of components because we have to find out the friction forces. So to do that, you must know the value of the normal force, because you know the friction equal to n into mu. So you know the mu is given over here. Whether you want to determine the kinetic friction or static friction um, doesn't matter. You need to know the value of n, the normal force. So to determine the normal force, you must know the component in the normal direction. So yeah, that is why I am going to determine n, which will be equal to, this is mg and this is the theta, same theta. You can determine it by some um, some geometry. So n will be uh, the weight is given over here, 300 pound multiplied by cos 36.87 degree. So that is comes out to be 240 pound. So now you know the um, value of normal force. So you can now calculate the static friction. First you will calculate the static friction to determine whether it will move or not. So if it is moving, then you will apply uh, kinetic friction. Then you will determine the value of kinetic friction. So let me first determine the value of static friction, because I don't know whether it is in motion or not. So the static friction will be mu s multiplied by n. So mu s is given over here 0.20 multiplied by, we have just determined the value of n, so that comes out to be 60 pound. Right now we need another thing, the force along the plane along downwards, like this component. So it will be mg sine theta, as it is mg cos theta, so it will be mg sine theta. So let's determine it. mm, like here mg cos theta, so mg is given cos, sorry, sine, this time I will use sine, mg sine 36.87 degree. So from that you can calculate the value of mg sine theta. Now uh, observe closely. You are now I can erase these stuffs. I don't need it anymore. I know the values. So you are applying force in this direction. So friction will act in the opposite direction, right? You are trying to make the motion in that direction. You are trying to move the block in this upward direction. So the friction will act in the opposite direction, right? So the friction will act in this direction, and the component of mg, which is mg sine theta, will also act in the same direction, like this. So the combined force in this direction over here, in the downward direction, in the downward direction in the plane, the combined force will be, let's denote it by F. So it will be the friction force is 60. The friction force is 60 plus mg sine theta, that is 300 multiplied by sine 36.87. So that comes out to be, sine can be determined from this triangle. So that comes out to be 240, I guess. Yeah, 240. So the downward force, let me now erase all the forces and make just one force. So the force, all the force, the summation of all the forces in that direction is 240 pound. And the upward force, like this force, I'm denoting it in the right side. The upward force is 100 pound. So we can see the downward force is greater than the upward force. So the block will move downwards. So the motion will be in downwards. So now we know the motion of the block. So find the value of the friction force. So now, as you can see, the block will be in motion. So now static friction will not be applied. We have to find the value of kinetic friction, because the block now is in motion. We cannot just determine the static friction. Static friction will not work here. Static friction will not apply here because the block is moving. So kinetic friction will apply. So now we can just simply find the value of kinetic friction. So Fk is nothing but the kinetic friction coefficient, which is 0.20 over here. You can see 0.20 multiplied by the normal force, which we determined earlier over here, 240. So this mm, comes out to be what, 48 pound, I guess. Yeah, 48 pound. If you calculate it, 48 pound will be your answer. So yeah, the friction force is 48 pound, and another answer, determine whether the block is in equilibrium. No, the block is not in equilibrium. The block will move in the downward direction. So we have finished our first question. So let's move to the next one. Yeah, you can see over here the solution is given, but yeah, you can have a look over here. just for referral. Yeah, I'm zooming it out. So now move to our next problem over here. The coefficient of friction are mu s equal to 0.40 and mu k equal to 0.30 between all surfaces of contact. Determine the smallest force P required to start the 30 kg block moving if cable AB is attached as shown and B is removed. So this is our picture for question number A and this is our picture for question number B. So let's solve. Okay, let's not erase it. Let's solve first for question number A. You have to find out the smallest value of P. You can see over here P to start the 30 kg block moving. So now for the first figure over here, let's try to imagine the FBD free body diagram for 20 kg mass, for 20 kg mass over here. So now for 20 kg mass, you can see the forces present are the force over here, the tension force will act in this direction, right, for 20 kg. And you can see over here, determine the smallest force P required to start the 30 kg block moving. That means the motion is just impending. It is not moving yet. It is the motion will just impend. So you have to consider it like the equilibrium condition, the forces in the right direction and the forces, the summation of forces in the left direction will be equal. These forces will be equal. As a result, it will be in equilibrium. That will be the minimum force. That will be the smallest force of P, right? That will be the smallest force of P for which the motion will impend. It will be in motion. So yeah, you can see over here the force P, like the tension will go like this. So P will act over here. So I can transform. So the tension in this wire will be, now I'm going to determine the tension in this wire. So let's denote it by T. I have to find out the tension first. So uh, the tension force will act in the downward direction and the friction force will be in the opposite direction. As the motion in rightward direction, the friction force will act in the opposite direction, which is in the left direction. So for equilibrium, T will be equal to the friction force. Yeah, in this surface, friction will occur, the surface over here. So the friction force will be, uh, you have to find out first the value of N, like N. So N will be mg, right? So the mass of the body is 20 kg. So the m will be 20 multiplied by 9.8. So that is our N. Now you need to know the value of mu, which is the static friction, because it is not in motion yet. The motion is going to just impend. So 0.40, which comes out to be, let me again use my calculator. It will be 78.4 Newton. So now you know the value of T, the tension force over here. So now for 30 kg block, for 30 kg, this is a very tricky one. For 30 kg block, you can see this tension force, the nothing is mentioned about the friction of pulley. So we can consider the pulley is frictionless. So this tension force will be same in the string, along the string, as the string is same over here. So for 30 kg, the tension force will act outwards to the object. Yeah, right. So the tension force for 30 kg will be in that direction. The direction will change for 30 kg because that is the nature of tension force. We know that, right? So that is the direction of tension force. Now you know the value of tension force. So for P, the you're trying to impend motion in the left direction, right? In that direction. So friction force will be in the right direction, right? So in the left side you have only the force P, and in the right side you have the force T plus the friction force. The friction forces, I must say, not the force. The friction this time will occur for this surface over here, point of contact, and another point of contact over here. So these two surface will impend friction, will apply friction to this 30 kg block. This time friction is applied in these two surfaces. So that is the main tricky thing over here. So the P, the leftward force, will equal to the rightward force. So it will equal to T plus. Actually, we can now input the value of T as we know it. So for instead of writing T, we can write 78.4 Newton over here. So 78.4 plus um, the friction forces. Now the friction forces will be for two surfaces, which is equal to 50. The whole mass is the normal force over here, 30 plus 20, that means 50 kg, right? So the normal force over this surface will be 50 kg. So for this first surface the friction force will be 50 into 9.8 into the coefficient mu s equal to 0.40. So plus the friction force for this surface. We have actually calculated this in the earlier section, because for the 20 kg block the T and the friction force are equal, so it will be 78.4. We know that, but still we can determine it by 20 into 9.8 into 0.40. So again it comes out to be what? It comes out to be 352.8 Newton. So that is the value of P for question A. Now let's move to question B. Now, as we have solved question A, the next part is very easy for now, for us actually. Now B is removed. What is removed? The rope over here is removed. You can see over here. So if you remove that part from here, so what can you say? The T will be vanished, right? Very simple. This time, this time the friction forces are still there in the opposite direction, right? Like here friction forces are there in the opposite direction, but now T will not be present here. So we can just erase T. We can just now subtract T. So from the previous answer, if you subtract the value of T, you will get the new value of P for the B part of the question. So for part B, P will be just the previous answer minus the value of T, which is 78.4 Newton. So this will give you what? 274.4 Newton. So that is the value of P for the part B of our question. So yeah, that was it. This time the sample solution was not given by our sir, because sir told us to do it by ourselves. Okay, now we have another problem number 3. A 120-pound cabinet is mounted on casters that can be locked to prevent their rotation. That means these casters over here will be locked. Why locked? So that you cannot rotate it like this. That's why it is locked. Yeah, because if you apply some forces, it will try to rotate, some rotation will occur. So we are ignoring that stuffs over here. The coefficient of static friction between the floor and each caster is 0.30. So the static friction coefficient is 0.30 for the surface and the contact of caster over here. Actually, friction is going to occur in that surface and in that surface, in these two surfaces over here. So determine the force P required to move the cabinet to the right, and the largest allowable value of H if the cabinet is not to tip over. So let's first solve the part A of our question. So for part A, it's the easiest one. Look, it's very simple. So the large no, the force P required to move the cabinet to the right. So you need to find out the value of P to move the cabinet to the right. So as it is in rest and you are trying to move it, you are trying to apply some motion in the right, the friction will act in the opposite direction. Very simple. You are trying to move the the cabinet in the right direction like this. So friction force will impart in the left direction, opposite direction. So friction will occur in this surface and this surface, right? And the weight of the cabinet is 120 pound. So as they are similar, this 120 pound will be splitted in these two surfaces, right? So this surface will have 60 pound and this caster will have 60 pound. This 120 pound can be splitted over these two casters like this manner. So the value of actually, you know, P will be the value of P, that means that P will be equal to the friction forces. So like we can count it as one, like if you do like this 60 into 0.30 for this surface, n into mu, which is 0.30 plus again n into mu. So this will give you what, uh, 36 pound. So that is the value of P. You can like think that in that manner that 120 pound are there, so P will be directly 120 multiplied by 0.30. So it's your choice how you think. So yeah, so the value of P is 36 pound for question number A. Now move to question number B. Let's move to B. Let me erase it. To find out whether it will tip over or not, you have to take moment, right? You have to find the moment. So you can take moment about any point. It's your choice. If the resultant moment equals to 0, that means no rotation will occur, no tip over will occur. But if there is some net moment, so rotation will occur. So that's why we have to find the value of moment. So I am taking moment about A, moment about this point A. Why? Because if I take moment about A or B, the moment for friction forces, like friction force was in that direction, so the moment for friction forces will be equal to 0, right? As we know, moment equal to r cross F. So the moment will become 0. That will give us very much amount of benefit. Moment about A. So if I try to find out the moment about A, what are the forces? One force is over here. The friction forces now can be neglected because the moment for the friction forces will be equal to 0. So one force over here and the other force, which is the normal force. Wait, I'm going to show it to you over here. Let me just find the moment. As we know, the 120 pound, the weight was splitted in these two surfaces, right? So the normal force was in that direction and in that direction. The value was 60 pound each. 60 pound over here, 60 pound over here. So for this 60 pound force, we can actually uh, count it the moment for the 60 pound as 0, why 0? Because for the condition of uh, for the condition of tip over, yeah, look over here, the largest allowable value of H if the cabinet is not to tip over. So when it is about to tip over, like you are applying some force over here and you are trying to tip over, so the contact will removed. As long as the contact is there, it will not tip over, but when it is about to tip over, the contact from A um, will be removed, right? It will be contactless in A because it is going to just tip over. The picture will now look like this. It's just going to tip over. It's just going to tip over. So when it is about to tip over, you can just ignore this force. So we don't have to worry about the moment for this 60 pound force. The moment will be equal to 0. So now if we try to do moment balance for this force, the moment will be force multiplied by the distance. The force is 60 pound and the distance is 24, which is given, and it will give anti-clockwise rotation. So the moment will be positive, and the moment for this force, this P force, will be about a force multiplied by the distance, right? So the force is 36, the value of P we have determined it, so it will make clockwise rotation, so the moment will be negative, minus force multiplied by the distance h, which we don't know. So for not to tip over, it should be equal to 0. So from that you can find the value of h. It will be what? 16 to 24 divided by 36 gives you 8 inch as answer. 8 inch. So the value of h will be 80. So the later part will be discussed by me very soon. I'm going to take a short break. Wait, I'm going to